Okay, let's start. Good evening, guys. Welcome to NEET World Institute and NEET World YouTube channel. Right. So, as you know that this particular series is for the EAPCET aspirant for 2026 examination in both medical as well as engineering stream. So, in this video particularly we are going to concentrate on the physics chapter, that is work, energy and power, right. So, till now we were discussing about many topics like straight lines, planes, laws of motion, units and dimension, measurements and errors, everything, right. And work, power, energy, like we have completed last 2-3 classes, right. If anyone would have not watched, you can watch that videos before starting this video, okay. Yes. So, now we in this class we will discuss about the next topic in the work, energy and power, right. We were discussing about work, we were discussing about energy, we were in that energy we were discussing about what is kinetic energy, what is potential energy, and particularly we were discussed about kinetic energy part separately, right. And in this topic we will discuss about the potential energy, right. Yes. So, when we talk about the potential energy, so basically we denote it by U, kinetic energy K, right. And this formula for the potential energy is nothing but mgh. So, this potential energy is nothing but, like we will say, it's a stored energy, okay. So, what is the unit of this potential energy? Unit, SI unit is same joules only, okay, same joules only. And what about the dimensional formula? Yes, that is one of the good question when you are coming to the potential energy, kinetic energy, the topic energy, right. So, when we talk about work, force and displacement, right now. So, what is work? That is force F dot d. F is nothing but mass into acceleration and this d, okay. So, this is kg and this is meter per second square and this is meter, right. So, can I say this one kg meter square per second square? Now, this one I can write in terms of kg is nothing but mass and m is nothing but meter, no, length square, and this is t power minus 2. So, this is dimensional formula for work. So, the same dimensional formula only for energy also, whatever energy, ml square t power minus 2 should be in square bracket, okay. Done? Okay. So, is that your doubt has been clarified, right? Okay, fine. Yes, same, no issues, like you can talk this like mass, gravity and height, no. So, what is mass? Kg, gravity is meter per second square and height is again meter. So, same we are getting, no, same, no. So, okay, you are having doubt in this kinetic energy, right. So, of mv square, this half is constant, leave about that, okay. So, mv square, no, mass is kg and this is meter per second the whole square, which is nothing but kg meter square per second square. Is this equal now? Is that your doubt has been clarified? Fine, okay. So, this is the major thing you need to remember when it comes to the potential energy. When we talk about one more point which is related to work, no, that is work is nothing but, work done is nothing but minus change in potential energy, which is minus of uf minus ui, which is nothing but ui minus uf is the work done in terms of potential energy, okay. Now can we do one question now? Okay, so the question is calculate the work done by the force F is equals to yj cap, to move a particle from 0 comma 0 to 1 comma 1, 0 comma 0 to 1 comma 1. So the following condition has been given, that is y is equals to x and y is equals to x square. This is the condition. Okay, y is equals to x and y is equals to x square. Yes, like whatever things now I am referring the book, like it's a EAPCET book, that questions I am taking out and I am solving those questions. Okay, yes. Now the force is given and the points is given, they are asking me to find the work done. So W is equals to integral of f dot dx. So I am taking this y in terms of x only, no, so that is why I have taken this dx. Okay, so otherwise if we talk about the force which is nothing but y, so dy let me take. Now if we substitute y as x, I need to take it as dx. Okay, so which is equals to integral of y dot dy. Now what is y? X. So I need to integrate with respect to x, no, I need to integrate with respect to x. So integral dx. So from which point to which point? 0 to 1. This is my x1, this is my y1, this is my x2, this is my y2. Okay, so x1 to x2. So if what is the integration of x? So it is x square by 2 from limit 0 to 1, right? Okay, so 1 if I substitute 1 by 2 minus 0, which is nothing but 1 by 2 joules. So can you give answer for the second question? If y is equals to x square, can you give answer for this question? Yes, whoever watching in online also, they can give answer in the comment boxes, we can check it. Okay, got the answer? Yes. So answer is 1 by 3 joules. Okay, let us find now. Okay, let us find the answer. So it is work done is equals to integral of f dot dy, which is nothing but integral of y dot dy. So what is y in terms of x square? I should take it, right? So it is nothing but x1 to x2 x square dot dx. So how I can integrate x square? X power n is nothing but x power n integration is nothing but with respect to dx. So it is x power n plus 1 by n plus 1. So this is the formula, right? Okay. So it is x power 2 plus 1 by 2 plus 1 from limit 0 to 1. So it is x cube by 3 from 0 to 1. So 1 by 3 minus 0, which is nothing but 1 by 3 joules. So this is my answer for the second question. Right now, that's the answer. So can we go for the next one? Oh, wait a minute. Is this his camera is clear now? Is it visible? Okay. Thank you. Okay, fine. So the next one is, okay, completed. The next one is elastic potential energy. elastic potential energy. So formula is U is equals to half kx square, elastic potential energy, right? Okay, and next thing what we are going to see is what is the relation between the conservative force and the potential. What is the relation between conservative force and the potential? So conservative force is nothing but like conservative. What is conservative means? Like it is not wasted, we will say, right? No, it is not wasted. Okay, and one more thing, conservative force, non-conservative force we have discussed. So conservative force like initial and the final point only we are talking, not the path traveled, right? No, so the relation is first let me write the topic, force and okay, conservative force and potential, conservative force and potential. Okay, so F is equals to minus dou u by dou x, okay, the partial differentiation we will say. No, suppose F is given in terms of x, y or z. As of now we are talking about only one thing, like one axis, x axis. In case they are mentioning that, okay, in case they are mentioning that F is equals to fx I cap plus fy j cap plus fz k cap. If this is given, how should we take the potential? Yes, it's a good question. Fi, say fx, fy and fz, right? So minus of dou u by dou x plus dou u by dou y plus dou u by dou z. So this is the formula when we are talking about force in x, y, z and the potential relation. So minus of dou u by dou x plus dou u by dou y plus dou u by dou z, right? So if we take the minus will come. Okay, so this is the relation between the conservative force and the potential. Fine. Now suppose the potential curve has been given, like for example some curve has been given. Okay, now let me take any point over here, point A, point B, point C or point D, like this. Okay, so the curve is between the potential and the force, so let me write this U and this is F. Okay, now they are asking whether the points A, B, C, D which are mentioned here are stable or unstable. Oh my god, 1 minute, let me arrange the camera. I guess it's clear now. Fine. So whether they will ask the points A, B, C, D are stable or unstable. Okay, so for that what we should do? So when we are talking about a graph, there will be some equation, right? So what is that equation? Yes, that equation is having a relation between the conservative force and the potential. Okay, conservative force and potential. So how we will have a relation between that stable and unstable? That's the question. Okay, and how we need to find that it's a stable or unstable? Fine. Okay, that for finding that what we should do is, first point I need to differentiate that. Okay, I need to differentiate the equation, equate it to 0. Like I guess you have an idea about what is maxima and minima, which we have discussed in units and dimensions, right? Differentiation, equate it to 0 and get the value of the unknown terms like x, y, z or anything and keep that value. Again double differentiate the equation, substitute the value, whether the value is positive, negative or 0. If it is positive, it is a minima, if it is negative, it is maxima, and if it is 0, nothing, it's constant, right? Yes. So similarly the same steps we are following here also. Okay, First what we should do is, U equation will be there, equation of potential will be there, okay, equation of potential will be there. First one, this is, it has been given. Second one, what I should do is, suppose in terms of x they have given, okay, in terms of x, in terms of x. So du by dx I will do, equate it to 0, I will get x values, okay, I will get x values. Now third step what I will do is, d square u by dx square I will get, okay. Now I will substitute the values here, okay, I will substitute the values here. Now what I should see, we should check whether it is a positive, negative or 0. If it is positive, it is stable. If it is negative, it is unstable. If it is 0, it is equilibrium condition. Equilibrium condition. Okay. So first one, positive in the sense stable. Second one, negative in the sense unstable. Third one, 0 in the sense equilibrium. Okay. See, one thing we should remember, when they are giving the equation of u, I should differentiate. Suppose if they are giving the equation of f, I should equate it to 0 directly, because what is f? F is nothing but du by dx, right? Du by dx. This is the relation we know, the in the form of conservative force and the potential, right? No. So if u is given, need to differentiate, again double differentiate. If f is given, equate it to 0, get the values and you differentiate that value, sorry, equation, and take the values there. Okay. So this is the steps to follow to find the stable, unstable or equilibrium condition of the given equation. Okay. So now let's see the question. Okay. Okay. So first question, yes, a long spring when stretched by a distance x, as the potential energy u, on increasing the stretching to nx, the potential energy of the spring will be, the new potential energy of the spring in terms of u only they are asking. Okay. So initially there is a spring, okay, okay. So what they are saying, stretched by a distance x as a potential energy u. So they have stretched the spring to distance x and the potential energy is u. Okay. Now what they are saying is, they have stretched this spring by nx. So what is the new potential energy? Okay. What is the new potential energy? So what is the potential energy of the spring? We know it is of kx square. So initially this is my potential energy. Now what I should do is, u dash will be equals to 1 by 2 k nx, no, so nx the whole square. What I will get, 1 by 2 k into n square x square. So rearrange this term little bit. So n square into 1 by 2 kx square. What is kx? 1 by 2 kx square, it is u. So u dash will be equals to n square u. So this is my new potential energy. New potential energy of spring. Okay. So this is how we will solve the potential energy of a spring problems. Okay. So we can take down this question. We will go for the next question, that is to find whether it is stable or unstable. Okay. Done. So the next question we will see. Potential energy of a molecule is given by U is equals to A by x power 12 minus B by x power 6. Okay, this is the potential energy of a molecule. They have given that U is equals to A by 12 x power 12, A by 12 x power 12 minus B by x power 6. Right now? Now, where A and B are positive constants and x is in distance between the atoms, the system is in stable equilibrium they have given. The system is in stable equilibrium, but at what point? Okay, they are saying that this system is in stable, okay, stable equilibrium, but at what point? This is the question. So what I should do now? First I need to get the differentiation of that, because they have given the potential. Okay, so U will be equals to x by A, so A by x power 12 minus B by x power 6, right now. So what I can do is rearrange the equations. U is equals to A into x power minus 12 minus B into x power minus 6. I have taken this x power 12 to numerator, x power minus 12, x power 6 to the numerator, x power minus 6. Okay. Now differentiate it, du by dx. So minus 12 A into x power minus 12 minus 1 minus of minus 6 into B into x power minus 6 minus 1. Okay, minus 1. Right. So minus 12 into A into x power minus 13, this is plus 6B x power minus 7. So what I should do is equate, this is du by dx, equation 1, what I should do, du by dx as 0, no, equate it to 0. So minus 12a x power minus 13 plus 6b x power minus 7 will be equals to 0. So take this 12a x power minus 13 that side, what happens here? 6b x power minus 7 will be equals to 12a x power minus 13, x power minus 13. So we can understand here that 6 1s are and this 6 2s are, right. So cross multiply, like b by x power 7 will be equals to 2a by x power 13. So this I can cancel it out and this one remaining 6 will be there. So I can say that x power 6 will be equals to 2a by b, x will be equals to 2a by b power 1 by 6, power 1 by 6. If square is there, I can take the root, which is nothing but 1 by 2. If 6 is there, I can say that 1 by 6. So at x is equals to 2a by b power 1 by 6, the potential equation is stable. This is the point, and this is the x equals to 2a by b x power 1 by 6 is the point. Okay. So this is how we will find the answers for the given potential equation, whether they are asking to find it's a stable or unstable, whatever it is. Okay. Suppose they have not mentioned in the equation it's not a stable or unstable, whatever it is. Find the equation whether it's stable or unstable they are asking. So I got the x as x is equals to 2a by b power 1 by 6. So I can say that it is a stable equilibrium condition. Okay. Okay, so if it's completed, we can go for the next question. Okay, so now the question will be in terms of force if they have given. Okay, if they have given in terms of force, in the sense what we should do. So the question is F is equals to B minus 2ax. So find whether the equation is stable, unstable, or it is normal, neutral. Okay, stable equilibrium or unstable equilibrium or neutral equilibrium, 0, right now. So for this, what I should do, first I need to know whether they have given potential equation or a force equation. So why we need to know? U is given, I need to differentiate du by dx, again double differentiate d square u by dx square, but force is given, equate it to 0, enough. Okay, directly I can equate it to 0 and take again double differentiate du square by dx square. I mean single differentiation is enough, single differentiation, right? So force is nothing but du by dx only. So they have given du by dx only, so I can equate it to 0. F is equals to 0, which is nothing but b minus 2ax will be equals to 0. So b is equals to 2ax, x will be equals to b by 2a. One thing we can say that x is equals to b by a, right? X is equals to b by a, that's the point. Now differentiate that equation, what we will get? If I differentiate that equation, f is equals to, this is du by dx. So d square u by dx square will be equals to 0 minus 2a, which means this is minus 2a, right? There is no points to substitute, no variable to substitute there, it's a constant. What constant? Minus 2a is the constant. Okay, so I can say that since this is a minus, it's unstable. Unstable at which point? X is equals to b by a point. X is equals to b by a point, it is unstable, right? So this is how we will solve the question when they are giving in terms of, yes, in terms of force. Done. Can we go for the next one? Okay, so let us see some formulas and then we will go for the problems. Okay, so formulas like work we have solved, like work we got, then potential energy, kinetic energy and the energy, momentum with respect to kinetic energy, everything okay, fine, and potential energy with respect to work also we got. Then what is the relation between kinetic energy and potential, kinetic energy and the potential energy means okay, fine, let's like it's equal only. Kinetic energy and work, how we can say that work is nothing but change in kinetic energy, which is kF minus Ki. okay, kf minus ki, or else I can say this is of mvf square minus of mvi square, okay, of mvf square minus vi square. So, it will be nothing but work, it's nothing but work. So, somewhere we have solved this, we have seen this equation, right. V square minus u square is equals to 2as. I can tell that as, this is v square by 2 minus u square by 2, multiply m on both sides. So, mass into acceleration force, force into displacement work. So, this is 1 by 2 mv square minus 1 by 2 mv u square. So, here I can say 1 by 2 mv square kinetic energy final, 1 by 2 m u square kinetic energy initial, okay. So, work done will be nothing but change in kinetic energy, okay. So, next one, the power. So, power is nothing but it is the ratio of work done per unit time, work done per unit time. So, power is equals to work by time I can say, or else that energy by time also I can say, right. And another formula is power is equals to force into velocity. How we got that is work done is mass into acceleration into displacement, force into displacement, right, and divide by time, right. No, so this force into mass into acceleration is nothing but force, s by t is nothing but displacement by time is nothing but velocity. So, force into velocity is the another formula. So, these are the formulas for the power. And what is the SI unit is? SI unit is watt, okay, watt. What is the SI unit? Done. So, now we will see some problem here. Done. Okay. Now the question is 1 kilowatt motor pumps out water from a well of 10 meter deep. Okay, 1 kilowatt. Okay, 1 kilowatt motor pump. So 1 kilowatt is the power, okay, of motor pump taking the water out from 10 meter deep. Okay, like let me take that height as 10 meter, okay, 10 meter deep. Then calculate the quantity of water pumped out per second, only 1 second they are given, no, t is equals to 1 second. What is the mass they are asking? So, what is the mass in the sense, what I can do over here now? So, power is equals to work done by time. So, pumped out from the deep, like depth of 10 meter they have given. So, mass into gravity into height divided by t. So, 1 kilowatt, no, 1 into 10 power 3, right. So, 10 power 3 nothing but 1 kilo, no, like kilowatt they are asking, no. So, okay. So, mass is, I need to find, gravity is 10, height is 10 and 1 second. So, this 2 zeros and this 1 zero will cancel off and this is 10 kg. So, 10 kg is the mass for 1 second. If they are giving 2 seconds, it will be changed, it will be 20, 3 seconds, 30, like that. Okay. Suppose so, yes, the question is asked how much mass has been pumped out in 5 seconds. pumped out in 5 seconds in the sense P is equals to W by T, where is nothing but mgh by 5 T, no? Okay, let me take T, this is P. So 1 into 10 power 3 will be equals to m into 10 into 10 divided by 5. Similarly, this 2 zeros and 2 zeros will get cancelled off, remaining only 1 0, and this is 50 kg. So for 1 second 20 kg I can say, 3 second 30 kg, 4 second 40 kg, 5 seconds 50 kg, right. So this is how we will calculate when they are giving in terms of height and mass, second, like time, everything, okay. Okay, the next question is, one coolie takes 1 minute to raise a box through a height of 2 meters. Another one takes 30 seconds for the same job and does the same amount of work. So work done by the coolie 1 and coolie 2 will be equal, right. So work done by coolie 1 will be equals to work done by coolie 2, but what is the thing is, time is different. One is taking 1 minute, one is taking 30 seconds, okay. So 2 meter height they have lifted, okay. So which one of the following, so which one has the greater power, okay, which one has the greater power and which one has the used the greatest energy, okay. This is the question. So power, if I find, I can say like power is equals to work done by time, right, no, work done by time. So now I can say that power is equals to work done by time, T1 is equals to 60 seconds, T2 is equals to 30 seconds. Can you find now? H is equals to 2 meter, H is equals to 2 meter. Alright, don't worry, like mass is nothing but mass of the box only they are lifting, no. So mass of the box will be same anyhow, okay. So m1 will be equals to m2 equals to m only. Don't worry about that mass, only I need to worry about the time and the only time is the thing, right, no. Gravity is also same, nothing, no. So P1 will be equals to mgh by T, this is T1, that's it. So height 2 meter, gravity 10, okay, fine, mgh by 30 P1 and P2 mgh by T2 will be nothing but P2 will be equals to m, okay, sorry, this is T1 is 60, right, 60 mgh by 30, correct, no. So I can say this is 1 by 2 into mgh by 30. What is mgh by 30? It is P2. So can I say that P1 will be equals to P2 by 2, which is nothing but P2 is equals to 2 times P1, 2 times P1, right, no. So if I want to find, like I can say like this also, or P1 by P2 will be equals to 1 by 2, 1 by 2. So which one having more power? P2 as having more power because he is using less time to lift. Simple, no, like power is inversely proportional to time. So when time decreases, power increases, right? Yes, no? That's the thing. Time is low, power will be high. Done. We'll go for the next part of the question. So one more thing, like don't try to miss the next class, okay, like not next class only, like don't try to miss any of the classes, because every classes we will see like a topic questions like this. So today, as we have completed the topic of the work energy power, no, like, and we are seeing some questions, right, the basic questions how they can ask, and tomorrow like the full PYQs of EAPCET we will see only based on the work energy and power only, okay. Okay, the next question is the energy required to accelerate a car from rest to 10 meter per second. So what is the energy required to accelerate a car from rest to V is equals to 10 meter per second? How much energy is required? So energy required to accelerate a car from 10 meter to 20 meter per second, 10 meter per second to 20 meter per second. Okay, first thing let me tell that they have given some energy will be used here, that is W, okay, for example. So suppose 10 meter per second to 20 meter per second, what is the energy used? So can I say this work done will be equals to change in kinetic energy? So 1 by 2 m V square minus 1 by 2 m u square, correct, no? So what is the thing here? Mass, okay, W I will write 1 by 2 m I will take commonly outside, which is nothing but 10 square, that's it, 10 square. I will keep this as it is, and this energy is W dash will be equals to change in kinetic energy. So 1 by 2 m V square minus 1 by 2 m u square, so which is nothing but 1 by 2 m commonly I will take outside, 20 square minus 10 square, which is nothing but 20 square is 400, 10 square is 100, so 1 by 2 m into 300, and this is 1 by 2 m into 100, right. So from this two equations we can correlate the equations, no, like W is equals to, sorry, W dash will be equals to 1 by 2 m into 100 into 3, where this 1 by 2 m 100 is nothing but W. So W dash will be equals to 3W. So 3 times of the energy is required to accelerate from 10 meter per second to 20 meter per second, right. So initially what they have given, there is a car which accelerate from 0 meter per second to 10 meter per second, and the energy used is W. Now what is the energy required to 10 meter per second to 20 meter per second? Okay, so change in kinetic energy is nothing but work done, that's energy, right. And we have given that half mv square minus half mu square, we got some equation, keep that equation as it is, and the second part same thing, 20 square minus 10 square, which is nothing but 300 we will get. So this 100 into 3 times will take, okay, 1 by 2 m into 100, which is nothing but W. I have taken the W here, which is nothing but W dash is 3 times of W. So I require 3 times of that energy, okay. Suppose they are giving that, they are asking that from u is equals to 0 to v is equals to 10 meter per second, the energy used is W, okay. Again from 10 meter per second to 20 meter per second, what is the energy? Okay, what is the energy? This is W2 and this is W1 is equals to W. From 20 meter per second to 25 meter per second, what is the energy? Okay, this is the equation. Write the energy in terms of ratios, okay. So we got this, that is W1 will be equals to, which is nothing but W only, no. So 1 by 2 m into 100, where this one W2 will be equals to 1 by 2 m into 20 square is 400, 10 square is 100, so 300. So which is nothing but 1 by 2 m into 100 into 3. This is nothing but W. So W3. Okay, W2 is equals to W1 into 3. What about W3? So it is nothing but 1 by 2 m into 25 square is 625. Okay, and this is how much? Minus 400. So 1 by 2 m into 125, right? Okay, so simple thing I can say that W1 will be equals to our 1 by 2 1 by 2 1 by 2 m will get cancelled off. So W1, W2, W3, how much the values? Okay, no, this is the thing. So we have got this relation, which is W1 is equals to 3 times no, this is W2 is nothing but 3 times of W1. And what about W3? This is the answer, you need to get it. Okay, so this is the question. So get this answer while coming to the class while coming to the next class. Okay, get the answer. This is the question. Okay, and one more thing is, I need the answer for when they are going to 25 to 30 also, 30 meter per second also. Fine. Okay guys, with this we'll end this session of today's class. Okay, we'll end this session of today's class. Okay, we'll meet in the next class exactly at 4 p.m. in tomorrow. So bye bye guys, we'll meet in the next class. Bye.